Have you heard of this one when you're learning recursion? How about this one? Or this one? Or really? How about giving your house to someone else or your wife?
What did you say? I said stick it in your ass.
Well, that's what I would say. So, this video series is all about mastering recursion. I'm going to demystify the mystery behind recursion. Now, take some time to solve this problem by using recursion.
Yo, drop your glasses, shake your asses, face screwed up like you haven't hot.
I know y'all like to shake your asses, but did you take the time to write code and see if we can solve this problem using recursion? Let's solve summation problem using recursion. We want to add sequence of numbers. We can express this problem mathematically as summation of x of I with I going from 1 to n. We can expand this as sum of n equals these numbers up to n minus 1 plus n. This can be rewritten as we reduce the problem to a smaller problem that is similar to original problem. What is the size of the problem? The size of the problem is n, where n is the upper limit of the sequence. In the problem decomposition step, we reduce the problem by 1 unit. Let's find the base case. For this problem, the smallest instance of the problem occurs when n equals 1. We return 1. We can now look at the recursion diagram. The input is n. We want to add numbers from 1 up to this given number n. We reduce the problem by 1 unit. The result of the subproblem is the sum of the numbers from 1 to n minus 1. We need to add the n to the result of the subproblem to get the final result. Here comes the recursion fairy. Assume by induction, we know the solution to the subproblem. We need to add n to the result of the subproblem to get the final result. Here is the recursive solution. If we call sum with the argument 3, we return 3 plus sum of 2, returns 2 plus sum of 1. The sum of 1 call hits the base case. This returns 1. Now we can add 2 to the value computed for sum of 1. We can now calculate 3 plus sum of 2, which is 6. This is the result for sum of 3. So the addition operation is deferred until we know the value for the recursive call. The recursive calls take up space in the stack. This is called the call stack, and it takes up memory. Time complexity is O of n. The growth is linear with respect to n. Space complexity is n, since the stack grows with n. This is called linear recursion. Let's compare the iterative and recursive solutions. The while loop terminates when n reaches 0. The recursion terminates when n reaches 1. it hits the base case. In iterative solution, n is reduced by 1 to move towards terminating condition. In recursive solution, n is reduced by 1 to move towards the base case. Sign up for your free coding interview coaching call. Sign up for your free coaching call by going to codinginterview.coach.